Okay, today I'll start chapter 5, but I guess I will just cover one part of chapter 5, okay? I'll be taking attendance in the mid of, what do you call that, in the mid of lecture, okay? So make sure you guys give me your attendance before you leave the meeting. Okay, can you guys see the shared screen? Can, right? Okay, good. Okay, so chapter 5, basically we are stepping into specification and documentation. For specification and documentation, here you will be learning a few interesting things, okay? The first thing that you'll be looking at is all the different notation. What I mean by different notation, what are the ways you can document or you can specify requirement. So here comes your formal method. So the mathematical notation is one of the notation that you can use to specify requirement. Then the other one that you have already learned in the previous chapter, which is graphical notation. And then the common one, natural language, English or any other language. You just use the language to describe the requirement. So these are the different notations. You'll be learning all this in chapter 5. Okay, so let me show you. Okay, maybe I zoom like this. Okay, so if let's say I change to slideshow, can you see? Can see or not? You able to see just now the slideshow? No, because I need to change it as step, then only can see the slideshow. Okay. What should I do? Never mind. Now I just continue like this. Okay, so basically we are stepping into the third quadrant. So you can see the third quadrant is all about specification and documentation techniques. Okay, so you're already done with the elicitation, you're already done with the evaluation, and now you are stepping into specification and documentation. So your assignment, for your information, your assignment covers until here. You don't have to do validation and verification. I will do it for you. Okay, I will do the validation and verification for you. Okay, so you guys need to just do until specification and documentation. That's why your assignment title is SRS. Okay, it's not consolidated document, it is SRS. Okay. Okay, so what are the subtopics you'll be learning? To understand different techniques can be used in requirement specification, to evaluate alternative techniques on requirement specification. So you'll be comparing, basically you'll be comparing a few different techniques. Okay, now as introduced in chapter 1, okay, precise definition of all features of the agreed system. What is requirement? What is in the requirement document? Okay, rationale for options taken, organization in this of this in a coherent structure document in a form of understandable. So these are the basic things that you know about documentation, basic things that you have covered so far. You're going to look at specification and documentation in detail. Okay, so let me start. So basically these are the topics or outline of chapter 5. Okay, first you will be looking at types of specification. Then we're going to go through the notation for requirement specification. There are 1, 2, 3, 4. Okay, so natural language got two types. One is free documentation, meaning you are using natural language without any restricted format, any rules, nothing. Okay, the other one, the one that you are doing for assignment, is actually discipline documentation in structured natural language. The structured natural language here is the structure that you use to write the requirement. Like for example, the system shall, the system should, the system may, all these things are structure. So it is disciplined documentation. Then the other one is use of diagrammatic notation, which you have also learned and applied in your assignment, all your diagrams, class diagram, use case diagram, state chart diagram. And for this topic, chapter 5, we're going to learn one more diagram under specification, which is sequence diagram. Okay, then finally, another way to write down requirement, or another way to analyze and specify requirement, is formal specification. Got two: algebraic approach, both also using mathematical approaches. Okay, one is algebraic, the other one is model based. The one you are using for formal method is actually model based. Okay, so we're going to look at this two also. Then after done with all the different types of notation, we will touch into beyond functional requirements, specifying quality requirement. Quality, here you're going to learn in detail about non-functional requirements. So basically, I have explained what do you call it briefly, how non-functional requirements are specified when come to actual requirement. It has to be measurable. So all those things, right? So we're going to look at them in detail. And finally, guideline for writing excellent requirements. So I will go through the guideline. Okay. So today we're going to start with type of requirement specification. So you guys know, right, what is user requirement versus system? Anyone? Who can give me the difference between user requirement and system requirement? Who's interested in presenting? Can take over? Whose mic is that? Haushen. Haushen. Haushen from which group? Can someone WhatsApp him? Group 2. Can take over the presentation. I got no issue. I'm very tired. It's such a tiring day today. Okay, let me proceed. Okay, otherwise our lecture will be delayed. Okay, so you have already learned this too, right? In software engineering. So can anyone quickly tell me the difference so that I don't waste time? Anyone? What is user requirement? Or user requirement versus system requirement? When you collect the requirement from user, it is in the form of user requirement or system requirement? When you elicit requirement from users, right? Users meaning stakeholders. The requirement is in the form of user requirement or system requirement? Anyone? User requirement. So user requirement specification is actually high level abstract. Okay, user requirement is known as high level abstract requirement. Okay, so you see they are intended for use by people involved in the in using and procuring the system. Procurement, like what do you call that, like who spend on the system, who actually come up with the budget and other things about the system. Okay, so usually it is known as high level abstract. Okay, user requirement specification usually are written using natural language. Okay, natural language, because that's the initial form of requirement. So usually initial form given in natural language, easy to understand. Okay, you can include some diagrams and tables. Okay, so usually you will describe what services the system is expected to provide and what are the constraints of the system, okay, during operation. So these are the things. These are the things covered in user requirement. While what about system requirement? Okay, system requirement, when you collect the user requirement, you will go through the user requirement and structure the user requirement to become more precise and more detailed. So more detailed, more precise, it will become system requirement. So usually we'll have a proper structure form. Even though you are using natural language, you must have a proper structure when it comes to system requirement. You follow the what do you call that? You follow the format. Okay, usually accompanied by models. Here comes all your use case, class diagram. So that is system requirement. So in user requirement, just some tables and diagrams can be attached. But when it comes to system requirement, all the analysis are included. Okay. Then we have what else? Okay, yeah. And what you call system requirement, another name is actually functional specification. Here comes the word specification. Okay. Then usually we use system requirement to sign the contract. We are not allowed to use the user requirement to sign the contract because not detailed enough. Okay, who will be reading your requirement document? The moment you're done with the requirement document, right, who will be reading the document? Once you prepare the user requirement document, these are the people will be reading the document. Once you convert your user requirement to become system requirements, these are the people will be going through. No big difference. Okay, user requirement usually contract managers, while here you don't have contract managers. Okay, system requirement, system end user, client engineer, system architect, and software developers. So this is more, what do you call that? More specific. Okay. Okay. Now let's look at the notations. So notation. So now we're going to look at two types of notation first. Today maybe look at these two types of notation. So let me show you. If I want to go through the graphic, can or not? It will have enough time or not? Let me see. Because graphic notation or diagrammatic notation will take time because we have to revise all the diagrams that we have covered earlier. Then only start a new diagram, which is sequence diagram. I won't start sequence diagram today, but I maybe will do the revision, okay, of all the diagrams. If I do revision until which slide? Let me see. So if I do revision, yeah, so I stop here. Sequence diagram I cannot start. So yeah, can. So today I will do the revision of all the diagrams. So I cover until diagrammatic approach, but I will stop at all the diagrams that I have covered before. I won't start a new diagram today. Okay, so I have to do until 30. Okay, so let's start with the first notation. First notation is the what do you call that, natural language, without any format, without any restriction. So what kind of what do you call that, problems that you face, or what are the advantages of unrestricted natural language, meaning there's no any restriction on the requirement specification. You can just write in your own way. There is no format, there is no structure for you to follow. You can just write the requirement in the way that you want. Okay, so that is called unrestricted requirement, natural language requirements. So we call, another word is or another term that we usually call use is free documentation. What is good about this? You have to know pro and cons of each notation. So what is good about this notation? Unlimited expressiveness. You can write in your own way. There is no limit. There is no any restriction like what word can be used, what words cannot be used, nothing. So you have no limit in express something. It is communicability, meaning easy to communicate. Okay, easy to communicate. Everyone can understand. Of course, normal natural language, everyone able to understand. No training needed. Yeah, it's just normal language like you are communicating with someone. So there is no training need to be provided. So there is no training needed. It is easy to communicate and unlimited expressiveness. Okay. So these are the advantages of natural language, and you can write the requirement in your own way. There is no format, there is no structure. Okay, what about free documentation in unrestricted natural language? Disadvantages. Prone to many spec error and flaw because you have no structure, you have no format. What happened? It can cause confusion. It can cause ambiguity. You know what is ambiguity, right? Ambiguous. One requirement, one statement, but when different people read, they can interpret differently. They understand different things. So that is the meaning of ambiguous. That's the meaning of ambiguous. So one statement, one requirement, but when different people, different readers read the requirement, they can come up with different interpretation. So that is called ambiguous. So usually, right, this free documentation in unrestricted natural language can cause ambiguities. Okay, when cause ambiguity, what happen? It can cause confusion. Okay, this can lead to confusion. Okay, so like you don't know whether this or this interpretation A or interpretation B. You can come up with like different definition for the same requirement. Okay, so several requirement expressed in a single statement is another problem. I told you, right? I already introduced this word during the assignment. Okay, now comes the lecture. So amalgamation. Okay, what is amalgamation? Requirement amalgamation means one statement, but you have combined a few requirements. The first rule that you need to remember when you are writing requirement, one statement, one requirement, regardless how short, how long. Okay, for example, the system shall allow the users or the whoever, the customers to log in. The system shall allow the customers to log out. Very simple. So sometimes you feel, yeah, these two are related. Why not I just put in one statement? The system shall allow the users to log in and log out. Wrong. Okay, it is wrong. You are not supposed to write that way. That is called amalgamation. You have more than one requirement written in one statement. Wrong. Cannot. Okay, do that. Okay, so these are the negative part of free writing. Okay, or free documentation. Okay, discipline documentation, the one you are doing in your assignment, you are actually using more than one notation. Okay, for my assignment you are using two notation. You are using discipline documentation or structured natural language. Another notation that you are using is diagrammatic notation. You are using two notation for my assignment. You are using another notation for one of your other subject. Can you guess what notation? Basically, you are doing assignment for this semester using three different notation. So you are specifying requirement using three different notation. Out of four notation, the first notation, which is unrestricted natural language, the other three you are applying on your assignment. In my assignment, you are applying two. This one, discipline documentation or structured natural language, and the other one is diagrammatic approach. For another course, you are using another approach, another notation. Can anyone guess what course is that? You're listening or not? I'm talking to myself. Yeah, formal method, natural language, correct, good. Okay, the other notation that you are okay also applying is natural language, sorry, formal method. Okay, formal method, mathematical notation. You are applying mathematical notation for your formal method assignment. So basically for this what do you call that, requirement engineering, right, you are actually implementing three different okay notations. So not bad. Okay, so use stylish rules. So what are the rules? Let's go through very quickly. Identify who will read the document. You have to make sure the requirement written in the way, okay, the user can understand. You need to know who will be reading the document. Say what you are going to do before doing it. Make sure every concept is defined before you use it. Keep asking yourself, is this comprehensible? Meaning you can read it or not, you can understand or not. Okay, is it relevant or not, enough or not, complete or not. Okay, complete or not. Never more than one requirement assumption or domain properties in a single sentence. Do not put more than one, even though it's an assumption or it's a constraint or it's a requirement. Every time when you write any one of this requirement or assumption or constraint, you have to make sure one sentence, one, cover only one. Use shall for mandatory. See, mandatory. This is optionality, whether it's optional or mandatory. If mandatory, you have to use shall. Should, desirable. If optional, you have to use may or can. Okay, all these are rules, you need to follow. Avoid unnecessary jargons. Yeah, you don't have to make it so berbunga-bunga, like, very bombastic. No need. We are not testing the language. We are only looking at the requirement. How simple, you try to make it how simple you could. Okay, as simple as possible. Okay, supply diagrams for complex relationships. So that's why you are learning all these diagrams. You are using diagrammatic approach. Sometimes explaining in just sentences are not sufficient. You can explain better with diagrams. So comes all the diagrams. Okay. Okay, so now this is an example of table or diagram that can be included, like decision table. You know what is decision table, right? You have all the conditions and combination of different conditions. What are the actions or what are the steps taken? So you play around with the boolean, true, false. Okay. So when one of the condition is true and the others are false, this combination what happened? When all the conditions are true, what happened? This is one of the diagram or table that you can include, okay, to support your natural language requirements. Okay, now let's go through the template. I'm not going to spend much time on template because you are very familiar by now with the template. You have been using it since week 1 for your assignment. Okay, so usually identifier, what's the meaning, category, specification, a requirement which is specified. Okay, fit criterion, source, rational, interaction, priority, stability, and commonality. So I guess no issue, right? Okay, now instead of just going through this theory, I go practically. Okay, so for example, now fit criteria. What I mean by fit criteria, your statement must be measurable. Okay, for example, complement statement by quantifying the extent to which they must be satisfied. For example, the scheduled meeting, Okay, dates shall be convenient to participant. What do you mean by convenient? Okay, you are saying that the meeting dates must be convenient. So your system must come up with a date which is convenient for the participant. Okay, understand. But how can you measure this? How can you prove at the end of the project that this requirement have been achieved? No way, right? So you should write, instead of doing this, instead of writing like this, you need to write like this. Schedule data should fit the diary constraint of at least 90% of invited participants in at least 80% of the cases. So, meaning you have 100 participants, let's say. Your data, the schedule date, the data scheduled by the system, maybe automated, date identified by the system, the date decided by the system based on what do you call that, the constraint submitted by the attendees or participants. At least 90% must be fulfilled. 90% must be fulfilled to come up with the date. If you cannot find 90%, you cannot satisfy 90% of the invited participant, then better don't propose any date. Meaning, it's not measurable. You understand or not? So this is one example, just example of requirement which is measurable. Instead of writing like this, you should write like this. Okay. Look at the second one. Okay, let's continue. Okay, look at the second one. Info displayed or displays inside train shall be informative and understandable. You see here, this is very general. Why I say very general? Okay, the info displayed on the train, okay, fine. Informative, how can you prove that the info is informative? The info displayed in a train, how can you show that it is understandable? So you must have a measurable, okay, requirement. So how to come up with measurable requirement? You have to have your fit criterion. How to this is fit criterion, which is used for measuring. Okay, a survey after 3 months of use should reveal that at least 75% of the travelers found in train info displays helpful for finding their connection. So meaning, when what do you call that? When you release your system, right? You should ensure that you conduct a survey in 3 months after the system is launched. So in after 3 months the system launched, you need to conduct a survey among the travelers, and you should get 75% satisfaction from the travelers on the info provided. So this is measurable now. Okay, so you can see, right? So this is meaning, the meaning of fit criterion. Okay, so now discipline documentation, yeah, grouping rules, system objective, system component, task, conceptual object, software features. Okay, so put in the same section. So you know what, modularization, basically the same requirement with the same system objective grouped together, or the same component can put it together, or system what requirements that perform the same task, put it together. Conceptual object related to same object, put them together, or when they have same features also put together. So you can do grouping, modularization, when you present the requirement. So now let's show you the template which you are quite familiar. Introduction, you know, right, what you have in the introduction. You can refer back to your assignment. This is what you've been doing from the first week. Then the second one is general description, and the third one is specification. Okay, this one I don't have to explain again, right? Exactly same like your template. The content will be same. Maybe the structuring are slightly different. Different companies or different standard will have different template. Okay, now diagrammatic notation. I'm not going to touch the sequence diagram today. Sequence diagram will be the next class. Today I'm going to just go through all the diagrams that I have covered before. Then I'll let you go. Okay, so I'll just do quick revision on all the diagrams that I have covered in the previous lecture. Okay, now, who didn't attend my midterm today? unable to, was not able to attend my midterm today. I noticed two students were absent. One student have contacted me. Who is the other one? Yeah. Another thing, I cannot find out. You know why? There are seven students didn't mark attendance today. So out of the seven, right? Actually, five of you came. Two students didn't come. I'm not able to detect who came, who didn't come because I haven't started marking. So can you please let me know if you haven't marked your attendance? Can you please inform me through your class rep? So at least after marking the attendance, I can find out who are the students skip my midterm today. I noticed two students didn't attend, but I need to finalize everything by this week. Otherwise, I cannot start marking. Faster, please kindly contact me by today or tomorrow. I want okay, two information. Whoever forgot to mark attendance for the lecture, please inform the class rep. Class rep, please inform me. Second, I want you guys to what do you call that? Check if any of your friend was not able to attend. If you know, was not able to attend the midterm today, can you please inform me? I only have one name. I need to know who's the other one. Okay. So please, please. Otherwise, I need to check one by one test paper to find out, which is time consuming. Instead, I can just spend the time on marking. So please let me know who skipped the midterm test. I can do some arrangement if you have a valid reason. Always remember when you skip midterm test or any coursework assessment, you have to have valid reason. The valid reason usually medical or some family matters which are really unavoidable. Not simply like normal prayers or whatever, then it's not acceptable. It is not accepted by the FOC. Or, I cannot simply decide, it is not acceptable by the department or FOCS office. You should have a valid reason like medical reason or really some important family matters which you have evidence. What kind of family matters like that? Okay, or someone like accident, some very close family members met accident. This kind of really like very emergency related things or very very critical things. You have the evidence, you can really not retake lah. You can take the test on some other time. Otherwise, you will be given zero. You will be given zero. I forgot to remind you the other day. If you don't attend your midterm test and you have no valid reason, you will be given zero. I thought you have been here in TAF for so many years. This is your second or third year. You should know the rules, right? Coursework, you cannot simply skip the coursework assessment. It's not scheduled last week or last minute. I have been telling you that I'm going to do what do you call that midterm test in week 9. Week 9, obviously during the lecture. I have been reminding you since last week. So if you skip midterm test, you should have a valid reason. Otherwise, you will be given zero. You understand or not? At least if you are not able to come, you have to email me immediately before the test. At least if you email me before the test, I can try to help from my side. You don't wait until the test over and I find out there are two students absent today. Then I try to search who are you, who are the students, and then you come and tell me, Miss, I was not able to attend. Oh, then how to help you? Hmm? And the reason given is not really valid. So I just let the department to decide. Okay. So make sure you any not only my course, any course when you don't go for the assessment, you should have really a valid reason. If let's say unfortunately you slept off due to very heavy rain today, the first thing you should do, you go and get a medical cert or something. You have to find an alternative way to make yourself safe. You understand or not? I notice, I know today, unfortunately, it was raining heavily. Okay, traffic jam everywhere. Some places flooded. I heard. Okay, so I understand your situation. Even I reached late 10 minutes. But then, when you don't have a valid reason, I cannot simply allow you to take the midterm test. You understand or not? Okay, so the two students who skip my midterm test, please try to contact me. One already contact me. I want the other one to contact me as soon as possible. By today or tomorrow. Otherwise, straight away I'll be giving you zero. I cannot do anything. Okay? Now let's start with the diagrammatic notation. Good now. Okay, Pu Hong has something to present. All are having dinner, is it? Okay. Yeah, those who have forgotten to take attendance, please contact me through your class rep. Okay. Okay. Now, diagrammatic approach. Who can recall all the 4 conceptual modeling that I have taught you before? Wow. Wow. So young. Okay. What are the 4 models that I have covered? Anyone? Quick, quick. You don't want to go back? You don't want to end the class? What are the 4 conceptual models that I have covered in my uh, lectures, my last lectures? Context model, very good. Next, yeah, contextual model, interaction model, behavioral model, very good. One more. Okay, one more important one missing. Yeah, structural model, very good. So you have learned all the important models under this course, the syllabus under this course, but then except for one. There's one more left. But what do you call that? There's one more model left, which I'll cover in this chapter. Sequence model, the most complicated model among all the models that you have learned so far. Okay, so the sequence model, I will start from next lecture. Today, I will quickly go through all the models that we have covered under diagrammatic approach. Okay, or diagrammatic notation. Okay, let's look at the first one, context model. Okay, first of all, to complement or replace natural language. Okay, so if you ask me, we cannot really replace natural language. If no natural language, you provide only diagram, there is no way for anyone to understand clearly. I can guarantee you that. Okay, so until now, natural language is there, is must. You can complement. You can complement. You know what is complement? Natural language is like something lacking, so you provide some diagrams to make it complete. That is complement. Okay, so now usually when you provide your requirement, like your assignment, individual task, you all provide your requirement, functional requirement table, list all the requirements, then you come up with some diagrams. So that is complementation. You complete. Complement. Okay, so what are the graphical representation importance to ease communication? Yeah, sometimes when by reading all the long sentences, you don't understand a single thing. But by looking at the diagram, you get better understanding. You can communicate or you can convey your message to your client or customer easily with graphics. Okay, provide overview. But the problem, you know what? Not everyone can understand all this technical drawing. This is considered as a technical diagram. Not everyone can understand use case. Not everyone able to interpret class diagram. So diagrams are only, you need to provide training. See, natural language, you don't have to provide any single training. But when come to graphical representation, you have to make sure the person who is looking at your diagrams has the knowledge. Otherwise, no point. Okay. Then what else? Anything important? Yeah, of course. You need to what do you call that? It is considered semi-formal because declaration of items and their interrelationship in formal language, syntax and semantics. This is more on what do you call that? Formal way of expressing requirement. Okay, now without wasting time, straight away start with the first diagram that I have already covered. But you have to know that this diagram comes under diagrammatic notation. What is context diagram? You show the overall system, okay, and how the system that you're going to develop communicate with all the external entities. So the system usually communicate by sending or receiving data. So you need to show the data flow in and flow out from the system to the external entities. Okay, what is external entity? External entity can be the users of the system, can be another system, can be hardware, can be a data storage. All those things are known as external entities. So basically, context diagram shows the context, how the system communicate with hardware, software, network, data storage, blah blah blah. So basically, it shows the context of the system, what is outside environment of the system. Okay, so that is context diagram. Okay, next diagram, entity relationship diagram. So you guys remember what is ERD? I taught you before during database also, right? ERD. So I guess ERD, if you understand ERD concept clearly, then you know what class diagram will be very easy for you to do. Just the difference here, entity relationship diagram is for entity, while class diagram for classes. Entity diagram shows the data structure, while class diagram shows the code structure. Okay, so basically they are using the same concept. Okay, so now let's look at, okay, example of ERD. Okay, basically ERD will have all the entity name. Then you can actually show the attributes. This is optional. Some entity ERD diagram will include the attributes, some not. Depends on what tool or what notation you are using. Okay, now the way you express the relationship between the entities can be using different notation. Different notation, like you see, this is star, many. Some use n, some use cross foot notation. There are so many notation. Also depends on the tools that you are using. So you have to show the relationship between different entities. Okay, so there are three main types of relationship: one to one, one to many, many to many. When you have many to many, you have to resolve. You have to resolve by including associative entity. Okay, basically every entity you need to identify a primary key. Then when you link this entity with another entity, your primary key will be inserted into the other entity to link these two entities. So when the primary key of one entity enters another entity, it is known as foreign key. So all those things should be no problem, right? And what is candidate key? Can anyone recall what is candidate keys? Can I hear from you? What is candidate key? Who remember database? Who is planning to take advanced database in future? Can you recall what is candidate key? Anyone? Hello. Primary key, you all know, right? Yeah, alternative primary key. Very good. So one table, like for example, let's say here got no proper example, but let's say I have participants IC number and I have participants IC number and participants ID, participant ID, participant IC number. So you cannot, you don't have to make both as primary key. Of course, IC also going to be unique, participant ID also going to be unique. So these are the candidate keys. Candidate keys means all the alternative keys for primary key, all the possible keys to be a primary key. So now you choose only one to become the primary key. The rest will be candidate keys. Okay. So what is foreign key? As I say, the candidate key, the primary key when enters another table to link another entity, that is known as foreign key. Okay, who can tell me what is composite key? Composite key. Recall ERD. What is composite key? Also, I covered in my database lesson last time. What is composite key? Anyone? Hello. What is composite key? Yeah, the combination of two primary key to identify a record uniquely. With only one primary key, if you are not able to identify a record uniquely, then you need to go for composite key. Associative entity usually, right, will have a primary key repeated. Associative entity we usually will have primary key repeated. So when there are primary key repeated, what happened? You cannot identify the record uniquely. So how can I now make either you introduce another unique key to become primary key, or you can use two different keys, combination of two different keys to become composite key. The combination will be unique. So you are using two different keys to become composite key to identify a record uniquely. So that is composite key. Okay, good, not bad, you all remember. Okay, proceed. So data flow diagram, okay, context diagram. Just now the context diagram, you go further to the next level, become DFD level 1. So how DFD level 1 look like? Okay, let's show you. This is the DFD level 1. So how to get the DFD level 1 from context diagram? This system, right, very simple. This system breakdown. You break down the system into all the important processes. You show all the important processes involved in the system. So basically, when you show all the important processes, that is data flow diagram. So the same external entities exist. The same external entities you need to also present here. Then you have to show the same data flow in and flow out, but it's not from the system now, but it's from the processes. Where you come, where you get the processes from the system. Just now it is presented as a system. Now you break down the system to become important processes, and you still show all the data flow in and flow out from each process, you need to link the process with another process. Okay, and also you have to show all the data flow in and flow out from each process, and you have to also show all the entities. Okay, so that is data flow diagram. Okay, is data flow diagram suitable for object oriented projects? What's your answer? Is data flow diagram suitable to be used for a object oriented project? Anyone? Yes, no? No. Why? Because the object oriented is different approach. Okay, so it is object oriented approach, while data flow is actually structured approach. So there are two different approach. The way they describe the system is totally two different approaches. So you cannot use data flow diagram by right for object oriented environment or project. Okay, the next one is use case diagram. Okay, what is use case diagram? You learn use case diagram under interaction model. Basically, you identify all the users of the system, all the users, and how they are interacting with the system. When they interact with the system, obviously they will be performing the function or they will be involving in the function. So you have to identify all the functions. The functions are known as use case. Each function is a use case. After putting in all the use cases, then you identify all the participants or all the what do you call the users, and then try to show the interaction. That's why it is known as interaction. How the users interact with the system, basically. Okay. Then we have what do you call that? Sequence diagram. Okay, we have sequence diagram. So sequence diagram will be covered. Okay, in the wait. Let me see whether I can go further. Okay, I start giving you introduction first. Okay, then I will stop first. Okay, I give you introduction about sequence diagram. Okay, what is sequence diagram? Okay, what is sequence diagram? Sequence diagram is another diagram that can show the interaction between the user and the system. Okay, it shows the interaction between the user and system, how user interact with the system. So basically parallel composition of timeline. You will include timeline in your sequence diagram. You see the other diagrams, you don't talk about timelines. So consider this diagram have more things. You have more things in this diagrams. Okay, pairwise directed interactions down timeline. Okay, I'll show you the sample and explain using the sample. Okay, so now let's look at the sequence diagram. Have you learned sequence diagram in any lesson before, or any class, any other course? Sequence diagram? Yes, no? You got learned before in any other course before earlier? No. Yes, no? Oh, got learned, but then forget already. Okay. Show an interaction between lifeline. So basically, right, there are few lifelines. Okay, who can have the lifeline? Who can have the lifeline? Lifeline means how long you live, right? Like lifespan for human, how long I live since I born until I die. So same thing. Every object in the system is created and obviously will be killed, will be destroyed, will be deleted. Okay, so the state chart diagram, you see, you can see the state chart relationship between state chart and sequence diagram now. So basically state chart shows all the states of the object, right? So here in sequence diagram you show the lifeline of each object, how long the object survive, how long the object is active, how long the object is inactive. You show all these things. Okay, so that is basically okay about what do you call that, lifeline of the objects. Okay, what else I need to tell you? Wait. Okay, yeah, can be drawn in at different levels of details and to meet different purposes at several stages in the development life cycle, typically used to represent the detailed object interaction. Okay, the one all very confusing when you read this. I will show you directly and explain from the diagram. Okay, now how to draw the lifeline. Vertical dimensions show time. Vertical dimension, you know what is vertical, right? Okay, today I just introduce a sequence diagram, then next class I continue. Objects or subsystems or what do you call that, connectable objects. You show all the objects that interact with each other. Okay, on horizontal line. Horizontal line. Then messages are shown by a solid horizontal arrow. Okay, message that transferred from one object to another object shown on horizontal arrow, and it is solid, not dot dot, solid. Okay, the execution or activation, object active now. Let's say now you log in, right? You are online, so you are active. Who is active now? Student is active. Let's say you log in, you are using the intranet, so it will show student is online now, so you are active now, so object is activated, student object is activated. So that is known as activation. So of an operation is shown by a rectangle. Okay, relevant lifeline on the relevant or respective lifeline. Okay, let me show you now. This is a sample. So today I'll just give you a briefing on this before I end the class. Okay, this is example of sequence diagram. Listen carefully. This is an example of sequence diagram. This is the actor who performed the function. Who performed the function. How you draw the sequence diagram? You know your use case, right? Your use case diagram. Use case diagram. Where is the use case diagram? Your use case diagram. Like for example, this is one of the use case, right? For one use case, you can draw one sequence diagram. You understand or not? For every single use case, every single function. Very simple to say. Every single function, one sequence diagram. So when you perform a function, you show when I perform this function, how the actor interact with the objects. What are the objects involved? How do they react? That's it. Okay, again, when I perform the function, how the actor interact with the objects, and what are the objects involved when I perform the function, and what happened to them. So basically, this is what you explain in sequence diagram. So now tell me, who can tell me what function is this? This sequence diagram for what function? Only one function, one diagram for only one function. So what function is this? Anyone? Anyone wants to give a try? Hey, no one listening. No reply means no one listening. How if your final exam later got sequence diagram? No regret later. Better answer. Yes, correct. Add new advert to a campaign. This is the function. So basically, this is one of the function in the your use case module. So now my question: do you have to draw one sequence diagram for every function? So for example, here got 1, 2, 3, right? 4, 5, 6, 7. Got 7 function. Do you draw 7 sequence diagrams? What's the logic behind this? Do you draw, because I say one function, one sequence diagram. So do you draw the sequence diagram for every single function? Who can tell me? By right, you can or you may draw one sequence diagram for every single function, but it is not necessary. It is not necessary. We only pick some main functions, same like state chart. We don't draw for all the classes. Okay, but every class you can draw one state chart, but we don't draw for every single class, because some of the classes are just interface class, some of the classes like nothing much. Same thing here also, some of the functions like nothing much. So all the main functions, you want to show how the objects are interacting. So you only show for some complicated function or some very important function, not for all. Okay, so here for this, when you are very simple. Okay, when you are adding a new advert to a campaign, there are 3 objects involved. 3 objects. What are the 3 objects? Client class, campaign class, and advert class. So basically, client object, campaign object, and advert object. These are the 3 objects involved in this function. So who perform the function? Campaign manager. When campaign manager perform a function, these 3 classes or 3 objects involved. So now basically the sequence diagram will show how the interaction take place. That's it. So when a campaign manager try to interact, try to perform this function, so first what he has to do, you have to break down, your use case description table, all the steps. Basically, you will show all the steps and how the objects are reacting. Every step, which object involved and how the object react or responds. So for example, campaign manager will try to get the name. Get the name from which object? Client object. After getting the name, getting the name, how long does it take? how long client object takes to return the name. So you see, not big bar. The rectangle shows how long the object is active, how long the object is activated or executed. So you see, short bar means it is only active for very short time. So getting the name from the client is like very quick, very quick. So the activation is very short period. After getting the name, okay, after getting the name, it will list all the campaign for this client. So for the client, what are the campaign under this client? It will list all the campaigns. So it will show basically all the campaigns. After listing all the campaigns, so when listing the campaign, you need to know the client, who's the client and what are the campaigns. So basically, you both objects are involved. Okay, I mean both objects involved, and you need to use a loop because there are more than one campaign. After listing all the campaigns for this client, you list advert. You have to choose one of the campaign. Okay, because you want to add advertisement for one campaign, right? One of the campaign. So now after looking at all the campaign, need to get which campaign. So now getting the campaign, see, campaign is activated. So after getting the campaign, now for that campaign, you need to get all the existing advertisement. Okay, because you're going to add an advertisement, right? So you need to get all the details of the campaign so that you can add advertisement for that campaign now. So another loop comes in, okay, where you try to get all the details of the campaign, okay, which you would like to add an advertisement. So when you try to add advertisement, okay, a new object is created because you are creating a new advertisement. So basically a new object is created. So this is how you show a new object is created, a new advertisement is created. Understand or not? So now I repeat the notation. This is the use case or the function. This is the function that you are performing the, or you are presenting the sequence diagram. Basically, sequence diagram will have an outline. Then first start with the actor. Okay, usually one actor, because one function usually performed by one actor. If you have more than one actor, then you have to show more than one actor. So usually a campaign manager perform this function. What are the objects involved? These three objects involved. Every object will have its lifeline. What is lifeline? Dot 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 line. So the lifeline, okay, dot dot line. Okay, how long you draw? Usually you just stick to same length of what do you call that, line for all. Okay, then every time when the object is activated, you show the activation with a bar. Okay, with a bar or rectangle. Then if let's say what do you call that, there is any loop involved, there are more than one execution, then you need to put a loop like this, then you label the loop like this. Okay, when a new object is created, this is how you show the new object. You see the symbol of object is just rectangle, right? So a new object is created when the advertisement is added to the campaign. So a new advertisement is created. So this is how you do. Okay, any question? Any question? Okay, now I have a question since you guys got no question. Okay, when the campaign manager request for the name, request the name of the client, campaign manager request the name of the client. Why there is no response line? This is what do you call that, action. Why there is no reaction? This is request. Why there is no response? Anyone? Is it compulsory to draw a response line? Anyone? If you can answer this question, then we end the class here. This is a request. Where is the response? Why there is no response line? It's a solid line, solid arrow, request. Request. Why there is no any line showing the response? Anyone? Hey, you all don't want to go back. Anyone is listening? Is anyone listening? Okay, no need to talk about the loop. What about this one? Gate name. There's no loop, right? Gate name. Gate the name. So meaning you are getting the name of the client. When you are getting the name of the client, you should get the response, right, where the name is written. The name, the requested name is written. So where's there is no line to return the name. Not even now. Okay, good try. But even no loop also, you still need to talk about. Let's talk about this one. There is no loop, right? Why there is no response line? Okay, that is good part of sequence diagram. Sequence diagram got activation, activation bar. So at the end of the activation, obviously when the bar is activated for this long, at the end of the activation, the response is sent. So when you don't draw the line, it is understood the response is at the end of the activation. So that's why since you have the what do you call that the activation bar on the lifeline, you don't have to really show the response. Showing response is optional, but if you don't show, it is understood every request at the end of the lifespan there is a response, or at the end of the activation there is a response. Is that clear? So all this now there's a response at the end. Okay, but you don't have to show. Is that clear? I will show you one example with the response line in the next class. Okay. Okay, I think that's all for today. I don't want to start with the sequence diagram because it's a very complicated diagram. I want to go in detail, so I prefer face-to-face class. So you guys, I don't even know how many of you are really listening to me. Okay, what about the attendance now? So class rep, can you, how can I check the attendance? 113. So there are 20, no, there are 19, no, not 19 actually. 18 students absent today. So how do I find out the 18 students who are absent? Not 18 actually. When I stop sharing, it will become lesser, right? There are 19 students absent today. So class rep. Okay, can you check for me when I ask them to raise hand? Can you check who are the students absent for each group? Okay, group 1. Can you please raise your hand? Group 1. Class rep, help me to check. If class rep absent, please let me know. Then I need to check. Hey, group 1, faster raise your hand. If you don't raise your hand, then no attendance for you. Quick, quick, quick. I want to end the class. I know, night time, you have a lot of things pending. Faster. Ayo, I don't think 9 students only. Group 1, so the others are not listening. See, very obvious. So class rep, can you help me to check who are the students absent today? Okay, group 1, please raise your hand. Last call. Group 1, raise your hand. Okay, group 2, raise your hand. So far group 1, I only saw 11. Okay, group 2. Group 2. Group 2. Group 2. Okay, group 2. Yeah. Oh, group 2 also, not everyone is. Okay, group 3. Raise your hand, please. Group 3. Group 3. Wow, see, group 3 so good. This is what I want. Group 3. Okay, good. Group 3 class rep, please take down. Group 3. Good. Okay, group 4. Group 4. Not bad. Group 4. Okay, group 4 anymore? Group 4. Group 4. Okay. Group 5. Group 5. Okay, group 5, please raise your hand. Group 5. Okay, not bad. Also, group 5. Okay, group 5. The others, please put down your hand. Group 5 only. Group 5. Okay. Group 6. Group 6? Any more group 6? Okay, group 7. Class, group 7. Group 7? Group 7? Okay, group 7. 1, 2, 1, 2, plus 4. 6. 4 absent today. Okay, group 7. Any more? No. Okay, fine. So overall, I can see 115 now. So 16 students. I think it's including me, right? Wait, let me check. Never mind, I can see who are the students invited and who are the students not here. Invited students are not here. Okay, fine. So that's all. Thanks for attending the class. So basically, I have covered, like I have done the notations, 4 different notations, okay, to specify requirement, to document requirement, 4 notation. But I haven't covered all 4. I have introduced to you what do you call the restricted natural language, and then restricted natural language or structured natural language. And then the graphic we have done halfway. So there's sequence diagram left. Okay, then after that we will go through formal method. Okay, so there are 4 things. Okay, so basically this 4 very important for this chapter. Okay, so I think that's all for today. I will see you in the next class. Okay, good night. Thank you for attending the class. Bye. See you.